1886 was the big year when gold was discovered in the Witwatersrand. But then again, there was a problem because to produce that gold, water was required, which was not sufficient. That is when Rand Water was established, the year being 1903. Until this very day, they're still providing us with water. This is a story of how Rand Water is safe-proofing our future. By 1906, the annual daily consumption of water supplied by Rand Water was about 11 milliliters a day, and it has been growing ever since. In fact, Rand Water has managed to augment its water sources to meet the growing demand.
My name is Simon Baba. I'm the Senior Manager, Capital Projects under the Strategic Asset Management Division. Our division is one of the divisions under Bulk Water Services portfolio, which is headed by Chief Operating Officer. Rand Water is actually celebrating its 110th year this year. Obviously, it was founded in 1906, only concentrating on supplying some mining industries around Johannesburg. It has since outgrown to be an organization that, those days it was supplying about 1 megaliters per day. Today we're supplying in the region of 5,200 megaliters per day. So as an organization, it has grown. How then do we move from the organization that was seen to be a small organization to an organization whereby, we grow and achieve the strategic growth of the organization?
Strategically, Rand Water is focusing more on growth, social and economic development, namely expansion of geographical area, innovation, rural development, domestic and international partnerships. Rand Water's vision is to be a provider of sustainable, universally competitive water and sanitation solutions for Africa.
There's a saying that water is life and sanitation is dignity.
Rand Water relies on intensified catchment management to ensure that our source of water is protected from pollution, as it can become expensive to treat polluted water. As people keep flooding into cities in a bid to find a better life, the demand for water keeps rising. As we augment our infrastructure to meet the demand, we also embrace the water demand management interventions, including water-saving initiatives. We believe in equilibrium between supply and demand, since we know that there's approximately 38% of unaccounted for water in the entire network. Rand Water already boasts an existing network of over 3,056 kilometers of large diameter pipeline, feeding 58 strategically located service reservoirs. Construction of the B17 and B18 pipelines will augment the existing B4, B6 and B10 pipelines, which operate in parallel as a network.
These are pipes designed in the past between 1960 and 1983 that were laid by Rand Water to get water from the Vaal through to Johannesburg. They range in diameter between 1.7 meters and 2.3 meters. And they span from Suikerbosch pumping station through to Palmit pumping station. It's about 40 kilometers in terms of length. Through these pipes, Rand Water pumps approximately a quarter of our total supply, getting water through to Johannesburg, Johannesburg Water, Kuruleni, as well as Tshwane in the far north of our network.
My name is Ricardo White. I'm a program manager for Rand Water within the raw water system. The goals and objectives of the B17 are basically split into two in terms of its goals. The immediate short-term goals or medium-term goals is to allow the neighboring pipelines of Rand Water to be maintained. So the B17 and B18 pipeline will act as a buffer during those maintenance periods of the existing infrastructure. The long-term goal is to supply Palmit and the Mapleton systems with the additional 600 megaliters per day of purified water.
The pipe route that it follows is from the Vaal Dam through to Palmit pumping station. The existing pipe that is being laid, the B17, it's similar in size to existing pipes that are in the ground.
The B17 is an all-welded steel pipe with a diameter of 2,100 millimeters using a variety of steel grades along its length. Initial portions of the pipe are self-supporting thick 18 millimeters by 46 steel. As the pipe travels uphill, it can theoretically be made thinner. But pipes with this large diameter are prone to collapsing under both the mass of the soil covering it and turning pipes on and off.
So what Rainwater has done and has done in the past is to use pipe stiffeners along the length of the pipe every couple of meters, and that enables the economical use of thin steel for approximately half the length of the pipe. The B17 is coated with rigid polyurethane on the outside, and internally it uses an epoxy coating, whereas B18 uses a kind of epoxy that's biofilm retardant. So that enables the pipe in that sense to prevent growth of biofilm on the inside, and it improves the life of the pipe. In terms of design life, we're looking at about 75 years that we should be able to get out of the B17. If they look after it in terms of regular refurbishment, we should be able to get something closer to 80, 90 years out of the B17 life.
The B17 B18 design is an up-to-date to standard infrastructure design. It's really uniquely designed. It's a 2.1 diameter pipeline that's aimed to supply 600 megaliters of water to the Palmit and Mapleton systems respectively. The design is of such unique standard because of the size of the pipe through the area that we're going, which is a generally dolomite section. So Rainwater is quite unique in delivering such designs.
Effective, safe and reliable water supply is of utmost importance to Rainwater.
My name is Eugene Berger. I'm the resident engineer on the B17 B18 pipeline for Option A. Option A entails the installation of 18.2 kilometers of 2.1 diameter pipe, 3 kilometers of 1.3 diameter pipe, and various cross connections to existing pipelines.
My name is Tata Tevape. I'm the resident engineer on the B17 B18 project.
Contract for Option A was awarded in March 2013. Construction started in April 2013. Phases of construction entails the following: clearing and grubbing, that's to allow access to the construction site. If any rock is encountered, a specialized blasting contractor would be employed to blast the rock and remove it.
What they usually do is to ensure that they excavate a length of about 2 kilometers, and that is in an open field area. After completion with the trench excavation, then they'll start doing the trench preparation in preparing for installing the pipeline. After installing the pipe in the trench, that's when then they'll start preparing for the soilcrete. The soilcrete is a bedding that's done for the pipe to lay on into the trench.
After excavation has been completed, pipe installation will be done. That entails field welds, repairing the protective coatings of the joints, the internal and external lining. That will be followed by backfilling of the pipeline.
The backfilling of the pipeline is done in layers of about 9 layers up until the top of the pipeline. Each layer is 300 millimeters thick in layer. And when it's compacted to about 90 to 95% hot ashdod compaction. Once the pipeline has been backfilled all the way to the top of the pipe, then the second stage of backfilling will commence. The pipeline is backfilled all the way to reinstatement level.
That will be followed by pressure testing of the pipeline, then reinstatement of the working area.
After the reinstatement level, then we have to look at how the rehabilitation process is going to take after the pipeline has been laid.
That will be followed by handing over the pipeline to operations of Rainwater.
Employees' health and safety plays a very important role in the whole construction industry. My name is Lerato Mushanyana. I am the Health and Safety Officer for B1718 project. My role is to ensure the contractor complies with the relevant statutory requirements and Rainwater specifications.
Some of the high-risk activities on this project include deep excavations that must be properly barricaded to protect employees and community members from falling into the trenches, The usage of heavy construction equipment such as side booms, cranes, etc. must be operated safely and maintained on a regular basis. Working closely to power lines whereby safe clearance distance is to be observed. Blasting operations that need to comply with rock procedures by the contractor. Large traffic movement of which the traffic management plan needs to be implemented in accordance to municipal regulations. At the B17 and B18 pipeline projects, health and safety is imperative.
I am Elmon Mbombi, the Environmental Control Officer for the B17 and B18 project. As Environmental Control Officer on site, I am guided by legally binding documents in monetary compliance.
Some of Elmon's roles and responsibilities include auditing compliance with the commitments set out in the Environmental Authorization, Water Use License and Environmental Management Plan, as well as overseeing the work carried out by the contractor and the subcontractors to ensure compliance with the conditions set out in the Environmental Authorization, Water Use License and Environmental Management Plan. As an environmental control officer, Elmon carries out inspections on a weekly basis, compiles weekly and monthly reports, and conducts weekly water sampling. Rand Water is about growth, operational excellence, high performance culture, positive stakeholder engagement, and financial viability.
Rand Water always aligns its program with the national development plans with regard to job creation. The 17-18 pipeline takes pride in its job creation drive.
My name is Fatima Puta, 36 years of age. I'm employed by B17 projects since 2013. Since I started here, due to my skills and other knowledge of construction, taking opportunity to be a supervisor on earthwork, which include excavation, bedding, backfilling. Some of activity are just right behind me. As you can see, the guys, that one of activity which is backfilling.
B17 and B18 pipelines is Rand Water's guarantee to continued supply of water, which in turn enables the organization to generate additional revenue over time through additional sales as a result of augmented supply.
The manufacturing of the pipe has already impacted on the greater South Africa in terms of job creation. We had 2 contractors appointed, and both of them at construction peak had on average 600 people appointed, local labor as well as semi to skilled labor force.
The story of the B17 and B18 pipelines project ensures that the Rand Water does a better job of offering water services to the people of South Africa.
Rand Water is in the business of providing a sustainable supply of potable water to South Africa.
B17-18 pipeline will ensure continuity in water supply with no interruption due to capacity availability and also meeting future quantities and quality aspects.
We have to make sure that over the next 20, 40, 50 years, we supply a sustainable amount of water. We've got a number of projects coming up next to ensure that happens.
We are on the growth path, and is the strategy that will lead us to the 2030, and we see Rand Water being one of the best utility in the world in the space of water and sanitation.